Alrighty, let's finish up section 5-2, verifying trig identities. Got a few examples here to share with you. Okay, the first one, double whammy. We got part A and part B. Let's start with part A naturally. We've got tan x times cosecant x is equal to secant of x. So let's see what we got on this one. And I should have pointed out, if I drag that back down here, converting to sines and cosines. So the strategy here, convert everything into some form of sine or cos. So let's see, this first tangent. Tangent is sine over cos, sine x over cos x. And then our next term, I'll underline in red, cosecant x. We're multiplying there. Cosecant is 1 over sine x. And we want that to be equal to secant on the other side. So let's see, we have a cancellation on the diagonal, leaving us just 1 over cos x. 1 over cos is a reciprocal, and that's the same as secant. And that's what's on the other side of equal. We have verified the identity. Turn everything into sines and coses. Now, in letter A, notice the left side was multiplied and the right side was a single term. No problem. Now, in letter B, we've got two terms on the left where we're adding stuff together. On the other side, it's multiplied, a single term. A lot of these are going to work out the same way. We are going to work on the left side here, and of course, just like the directions gave us the hint, we'll turn into forms of sine and cos. So this tangent is sine x over cos x, plus cotan is cos over sine, cos x over sine. Now, if you're thinking cancel on the diagonal, it cannot do that because of the plus in between. It has to be multiplied or across an equal sign. So let's see. I guess we're going to add the fractions. That's another strategy they gave us. If you have two fractions, try adding them or subtracting. So here our denominator is going to be cos x times sine x. Denominator multiplies straight across. This numerator sine is going to get multiplied by the missing denominator under it, which is sine. Sine times sine is sine squared. Plus, our other numerator over here is cos, and that's going to get multiplied by what's missing under it, another cos. Cos times cos is cos squared. Ooh, I hope you see where this is going. Sine squared plus cos squared in that numerator. That is a 1. So now we have, let me write it more over here, 1 over cos x times sine x. Now, if those chunks in the denominator were added or subtracted, we could not break that into separate fractions. But since they are multiplied, we can give that numerator 1 over cos times same numerator 1 over sine. Because if we were to multiply back straight across, we'd be back to where we started. We're about to fall across the finish line. This 1 over cos, well, 1 over cos is equal to secant of x times 1 over sine, that's equal to cosecant of x. And that was our finish line. Good job. Okay, so example 4, convert to sines and coses and see what happens. Ooh, what's all this writing? Recall from algebra that rationalizing a denominator using conjugates is, on occasion, a powerful simplifying technique. A related form of this technique works for simplifying trig expressions as well. For example, to simplify 1 over 1 minus cos, we would multiply the numerator and denominator by the conjugate 1 plus cos, and then our denominator becomes 1 minus cos squared. We've seen that in some of our examples, and that 1 minus cos squared turns into a sine squared. Now what they sort of did here is they dragged that sine squared out. So it would be 1 over sine squared. Since sine squared was in the denominator, we would drag it out and it would stay in the denominator. And then they have that quantity 1 plus cos. And then they turn the sine squared 1 over sine squared into this cosecant squared times quantity 1 plus cos. This expression is considered a simplified form of this because it is not in any form of a fraction. You might see that as the directions for an example or a homework problem. Write it so it's not in the form of a fraction. So when we're looking here at example 5, we've got the left side is secant of x plus tangent of x. The right side is cos over 1 minus sine. They just said that a non-fractional form is more simplified. So what we're going to do is work on the right side. This cos over 1 minus sine until it matches the other. Let me sort of tuck them up here. And I'm going to underline our finish line in red. And we'll start working with this stuff here. I underlined in blue. So I'm just going to copy that here. And then we're going to multiply by a conjugate. So top and bottom are going to get multiplied by quantity 1 plus sine x. Quantity 1 plus sine x. Now the parentheses are on there. I am not going to distribute the cos. So when we multiply across the numerator, it will be that cos that was in blue times our conjugate in the parentheses. When we FOIL out the denominator, 1 plus sine times 1 minus sine results in 1 minus sine squared. And that's why we use the conjugate. So there will be no middle term when we FOIL. And now for that denominator, we can actually apply a Pythagorean identity. Seen it a bunch of times already. 1 minus sine squared. Well, that's a Pythagorean away from cos squared. Now the numerator we had, the cos of x, which we did not distribute, times that quantity 1 plus sine x. Now, since the cos is outside those parentheses and they're multiplied, we can cancel. The cos in the numerator is completely gone, and our denominator cos is knocked down 1 power. So now what we have is 1 plus sine x in the numerator and a little old cos x in the denominator. Okay, let's take another look at our finish line up there in the left corner. I'll underline in red. Secant x plus tan x. Our numerator has a plus in it. It's 2 terms. Our denominator is a single term denominator. When you see that denominator is a single term, at least mentally break it into some pieces. Numerator 1 over its own cos x plus numerator sine x over its own cos x. Okay, ooh, we are close. Again, look at that finish line. Let me bring it down here. Secant plus tan. 1 over cos, well, that turns in to secant of x plus sine over cos, well, that's tan x. That's what we transformed the right side into. That was our finish line. We made it. So that was our algebraic solution. Graphical, of course, for graphical, we would just put each of those into TI-89. Y sub 1, we could do secant of x plus tan x. Kind of looks like a tan graph, but shifted around a little bit. And then this mess, cos over quantity 1 minus sine, would be the exact same graph. They would be identical. You wouldn't be able to tell them apart. So here are some for you to enjoy on your own. Pause the video and then see if you get them right. So this left side, we are going to convert into sines and coses. Cotan is cos over sine times secant is 1 over cos. Okay, on the diagonal, coses cancel. We're left with now 1 over sine x, and that is equal to cosecant x, and that was our finish line. Cosecant x is when the journey ends, and we made it. Letter B is one of our fraction ones. So the left side are these 2 terms subtracted. Let's turn those into sines and coses. Cosecant is 1 over sine minus sine is sine over 1. Oh, this is going to be interesting. Oops. Our denominator, if we multiply these 2 together, sine x times 1 is sine x. This numerator 1 gets multiplied by what's missing under it. That'll be this one, so 1, minus this sine x gets multiplied by what it's missing, so that's going to be a sine squared. Sine squared x. Ooh, 1 minus sine squared. We've seen that a bunch of times. 1 minus sine squared is cos squared over sine. Okay, here's where we're at, and look at our finish line. Look at that finish line. My advice for something like this, especially when the numerator is a square, denominator's first, or if that was reversed, I just say pull it apart. Pull that apart into its component pieces. So the cos in the numerator, we could break that up into a cos times a cos. Oops, what the heck am I doing? Cos times cos. Underneath, sine is to the first power. So we can only put sine under one of these. And it doesn't matter which because they are both the same. So I'm just going to put it under the left one. The right one will get a 1. And we are so close to the finish line. This cos over 1, well, that turns into that cos. And cos over sine, well, that's cotan. So there they are. Perfect. And verify this. Okay, we are going to work on the right side to make it into the left. Very similar to our example. I'm just going to copy our sine x over 1 minus cos. And the technique was multiply by the conjugate. That conjugate will be 1 plus cos. Okay. FOIL in the denominator. 1 minus cos times 1 plus cos. 1 minus cos squared. And then I'm going to leave that sine x outside. We're not going to distribute. And we'll keep the 1 plus cos as a quantity. All right. That denominator, 1 minus cos squared. Let me copy my numerator first before I get ahead of myself. So here, the 1 minus cos squared, well, that's sine squared. And I'm going to write it right under here. All right, we are getting somewhere. We are now down to a single term denominator. That's always a good step in the right direction. And we can cancel this sine x to the first, gone. And that will knock this sign down a power to sine x. So I'm just going to rewrite it just so it looks a little better. So now we've got 1 plus cos in the numerator, sine x in the denominator. So this we can break into separate fractions. I'll use my red ink and look at like this. So our first fraction will be 1 over sine plus blue ink cos over sine. Okay, we are about home. I'm going to just work my way up here. 1 over sine, well, that's cosecant, plus cos over sine, that's cotan. And that is our finish line. Once again, we got there. Beautiful. Is there another example? Yes, there is. Now, we always work with one side to get it to match the other. Sometimes you can work on the left side a little bit and then maybe take a break and move over to the right side and work on that one as long as you keep them separate. And the book says, in the first 5 examples, you've been verifying trig identities by working with one side of the equation, converting to the form given on the other side. On occasion, it's practical to work with each side separately to obtain one common form that is equivalent to both sides, as we are about to see here in example 6. So what I'm going to do, I'm going to use my black ink and draw a line. Let me center that up a little better. I'm going to draw a line right down the middle, and I'll use red to work on the left side. So we're over here. Now, I've said before, if you see a squared trig function with a 1 lurking around, always think Pythagorean. There doesn't have to be a 1 lurking around because we can always move that to the other side. If you look at your formula sheet, I'm going to do a little scratch work here on the right. 1 plus cotan squared is equal to cosecant squared. So if I want to get this cotan squared alone, I'm just going to subtract 1 from both sides. So I'm going to take out that numerator, cotan squared, and replace it with cosecant squared minus 1. Cosecant squared theta minus 1. Oops. Now that I've done that, look at this denominator right under it, 1 plus cosecant theta. Because there's a plus in there, I'm going to write that in the reverse order. Cosecant theta plus 1. Okay. Think back to factoring. X squared minus 1. This numerator cosecant squared minus 1 is just in the form of a perfect square minus a perfect square, so we can factor it. Cosecant theta plus 1 times cosecant theta minus 1. Okay, now look at that denominator. Cosecant theta plus 1 is in the denominator. Let me switch to black ink real quick, and we can cancel those like so. So what are we left with? Cosecant of theta minus 1. Okay, so we've worked on the left side. We've got it down to something kind of simplified, kind of nice. Let's hop over to the other side and see if we can do something similar. I'm going to switch to blue ink. And the beauty of this side over here on the right is our denominator is a single term. We just got a sign there. So let's break that into separate fractions. Numerator 1 over sine theta minus numerator sine over its own sine theta. Ooh, look at that. 1 over sine, well, that's cosecant last I checked, minus sine divided by itself is 1. And look at that. We got the left side and the right side down to the same equivalent expression. Fantastic. Okay. Here is one for you to try, and I think this is the last example of the section, or the last huddle problem of the section. So enjoy. Work on each side a little bit separately. It's very similar to the one we just did. Oh, no, don't we have another example? Oops. Oh, yeah, we do have another example. Duh. Yeah, so give this one a try, and then we'll have another example to enjoy after that. Okay, divider line down the middle. And just like we did in the example, that tan squared, we can use a Pythagorean to make that into secant squared minus 1 over 1 plus secant theta. Factor the numerator into a secant theta plus 1 and a secant theta minus 1. And our denominator is 1 plus secant, but we could write that in reverse order. Secant theta plus 1. And we have a cancellation. So we're left on the left with secant of theta minus 1. Time to hop over to the right side. Single term denominator. Numerator 1 over cos theta minus numerator cos theta over cos theta. Okay, 1 over cos, that is secant, minus cos over cos is 1. They are the same. Okay, now I think this is the last example. Yes. Two examples from calculus. It says verify this identity. Now, got some higher powers here. Tan to the fourth is on the left. That is the simpler side. So we're going to work on the right side until it looks like tan to the fourth. So notice on the right we have two terms. There's a minus sign in there. And we have a tan squared times secant squared and a minus tan squared. So we do have a common tan squared. Let's factor it out. Tan squared comes out. What are we left with inside the parenthesis? Well, we've got a secant squared in there. And then minus, we factored out tan squared entirely, so a placeholder 1. Okay, so we've got this tan squared. Pythagorean identity, secant squared minus 1 is equal to tan squared. On the formula sheet, it says 1 plus tan squared is equal to secant squared. So if we just move the 1 over by subtracting it, secant squared minus 1 is tan squared. Okay, we've got a tan squared times another tan squared. When we multiply like bases, we will keep the base and we will add the exponents. 2 plus 2 is 4. And that is the finish line. The letter B looks a little different. You know, here's our left side. This is our finish line. I'll underline in blue, because we've got a cosecant of the fourth there, and where we're starting already has a cosecant squared. So we're going to want to take this other junk and try to turn it into another cosecant squared somehow. Now I'm going to underline in red here, in the parenthesis, cotan x plus cotan cubed of x. So we are going to be able to pull something out of there. I'm going to come over this far. I'll need the room. First, I'm going to bring down that cosecant squared. And then we're going to factor out one of these cotan of x's from that parenthesis. So out comes a cotan x, and then we're going to have a set of parentheses with some stuff left in there. The first cotan we factored out was first power, so we need a placeholder 1 plus cotan cubed, when we factor out a cotan x, is now cotan squared x. Okay, Pythagorean identity time. This 1 plus cotan squared turns into cosecant squared. Cosecant squared of x, that is just a Pythagorean identity. And then we've still got these two terms here. I'll just switch to red ink for those. We've still got a cosecant squared x and a cotan x. Again, let's take a peek at our finish line right here. Cosecant to the 4th times cotan. Well, we've got our cotan. And then if we combine our two cosecants squared, we have a cosecant to the 4th of x. Okay, we made it. One more team huddle for you to try. And then we're done. Oops. There we go. So verify these. On the first one, your finish line is tan cubed. On the second one, your finish line is here, sine cubed times cos to the 4th. So pause the video and enjoy those problems. Okay, so for the first one, we have two terms. I'll underline in blue. We are going to factor out a tan x. And remember, our finish line there is tan cubed. So now we have a secant squared x minus 1 in the parenthesis. And secant squared minus 1 is going to turn into tan x. Tan squared x. And if we multiply the tan squared and the tan, we get tan to the 3rd x, which again was our finish line. Let's see here. Our finish line has a sine cubed and cos to the 4th. Now look what we got here is a cos to the 4th and a cos to the 6th in that same set of parentheses. So, and outside the parenthesis we do have a sine. So we're going to pull a cos to the 4th out of the parenthesis. Cos to the 4th comes out. What are we left with? Our first term we factored out entirely, so that's a 1, minus cos to the 6th. We pulled out a cos to the 4th, so that leaves a cos squared. Ooh, that's going to be a Pythagorean. And we've still got here this sine x. Sine x. So 1 minus cos squared, that's going to turn into a sine squared. And we've got times another sine x. And then that is multiplied by this cos to the 4th lurking out front. Ooh, so we are at the finish line. Cos to the 4th is part of our final answer. And then we just combine the sine squared and the sine to the 1st. And we'll get a sine cubed of x, which is also in our finish line. Okay, we made it. That is the end of 5-2. Here are some problems. There are some odds in there. They must not have had a good variety. For the evens only. So give those a try on page 360 in the book. When we are together in class, we're going to do some odds. It looks like I got some odds picked out here. Okay, I hope this video helped.